Hello everyone, hello. Hi, hello. Okay, today we're gonna be doing number system. So number system is a pretty easy chapter. First, we'll discuss about the different types of numbers. So first we have numbers called real numbers. Alright, we have real numbers. And within this we have rational and irrational. And then integers, whole numbers. But we'll focus on rational because this should be a rapid revision video. Now, what are rational numbers? Numbers that can be expressed in the form of P by Q are called rational numbers. Alright, so numbers that can be expressed in the form of P by Q are called rational. Now you can perform many operations on rational number. So we have several operations like addition, subtraction, multiplication, and division. Fine. We have addition, subtraction, multiplication, and division. Now addition is simple. We'll have some questions, okay? But then not in this video. We'll be solving. We have a separate thing for RD Sharma, which we'll be doing. So yeah, let's just continue with this. Now we have all these operations which can be performed on rational numbers. Now, we know that anything in the form of P by Q is this is the symbol for it belongs to a rational number, right? Now, let's say we have a decimal. Fine. Let's say we have a decimal. How do we find out whether this decimal is a rational or irrational number? Now we have a decimal. If the decimal is non-repeating and non-terminating, it's an irrational number. Fine. Okay. Now, under rational numbers, decimals can be of two types. They are terminating decimal, and non-terminating repeating decimal. Fine, non-terminating repeating decimal. So let's say I have a number like 1.2. It ends here, okay? So it ends with 2. So therefore it is a rational number. Now if we have 1.2 bar, which basically means we have 2 repeating, it's also a rational number. Okay? Now there are also stuff where you have to represent things in P by Q. So let's say we have our question as express 0.3 bar in the form of P by Q. Okay, so 0.3 bar in the form of P by Q. Let's say we take a number x is equal to 0.3 bar. Okay, now you notice that after the decimal you have 1 digit. Okay, so for that we just multiplied by 10, so we move the decimal point here, so we multiply both sides by 10, so we have 10 into x is equals to 10 times 0.3 bar. Now we have 10x is equals to 3.3 bar, because you move the decimal point forward, then you have 3 and so on. Now this is our equation number 1, this is our equation number 2. Now subtract equation 1 from equation 2. Okay, okay, so we have 10x minus x is equals to 3.3 bar minus 0.3 bar. Now we know that this is equals to 9x is equals to 3.3 bar minus 0.3 bar. Now 3.3 bar is basically 3.333, so 1 minus 0.3 bar, which is basically 333. Now when this 3 continues till like it does not end, so you notice that this entire thing cancels out and we have 3 as our result. So 9x is equals to 3, x is equals to 3 by 9, and so the answer is x is equals to 1 by 3. Okay, simple, got it. Now next is we have finding a rational number between two rational numbers. So, alright. So let's say we have a rational number 1 by 2 and then another rational number 4, sorry, 2 by 2. Now we have to find a rational number between 1 by 2 and 2 by 2. Okay. Now 1 by 2 and 1 basically. So how do we do this? We use this formula called, let's say we have this rational number a and this one b. Any rational number between it is a plus b by 2. Okay. Any rational number between it is a plus b by 2. 1 minute. Okay. Now coming back. So we have a plus b by 2. Fine. So how do we input? Now we input these values. 1 by 2 plus 1 over 2, which is equals to 1 by 2 plus 2 by 2 over 2, which is equals to 3 by 2 over 2, which is equals to 3 by 2 times 1 over 2, which is equals to 3 by 4. There we go. Now we got the answer as 3 by 4. So this entire thing shows that we can find using this method. Now let's say I'll ask you to find a rational number, an irrational number between two irrational numbers, root 2 and root 3. Okay, let's just start simple. Let's say I'll ask you to find an irrational number between 2 and 3. Fine. So 2 and 3. How do you do this? Now there is one formula. Fine. The formula is, if we have 2 q slash q apostrophe. Q is for rational, q apostrophe is the symbol for irrational. For then an irrational number between would be root of a times b. Okay, fine. Root of a times root of b. Okay, fine. Right now. So, but then there is one more catch. See, sometimes this formula doesn't work, okay? So, like, let's say if I take root 2 and root 3, it will work. So, like, root of A into root of B, okay? Now, root of 2 into root of 3, which is equals to root of 6. This is irrational, this will work. Now, if I say 2 and 8, no, it won't work. Because root of 2 times 8 would be root of 16 and all of that. So, we have done this. Now, let's go to representing irrational number on the number line. Okay. How do you do this? No. See, let's see. First, let's go back to 7th grade and remember our triangles chapter. In this triangle chapter, we learned about Pythagoras. Array, let me increase the thickness. We learned about Pythagoras theorem. Now, what does this theorem say? A square plus B square is equal to C square. Okay. Fine. So let's say if I have A is equals to B, A equal to 1. Now, if this is a right angle triangle, so I'll draw this. This is 1, this is 1. Now what will be this? So, I will use the Pythagoras theorem. 1 square plus 1 square is equal to C square. 1 plus 1 is equal to C square. 2 is equal to C square. C is equal to root 2. We have root 2. Now, then this is on. Now let's say I'll take. I want the hypotenuse to be root 3. How will I represent root 3? Now, first let's find the Pythagorean triplet for root 3. Now, 3 is equals to 2 plus 1. I'll just write it like this. Now, I need to get this 2, 1 and then this 3. So, basically I have root 3 squared is equals to root 2 squared plus 1 squared. This forms a Pythagorean triplet. Now, how do we get the root 2? We have 1, 1, here root 2. Now, from here, construct another triangle. This is 90, okay? This is 90, this is 90. Okay, this is root 2, fine. This is another triangle. Root 2, this is 1. Okay, this is always 1, fine. Not always, but then, no, for now. This is 1. Now, this will be root 3. Now, like that you will continue. Okay. See, root 2, root 1, 1, root 3, root 2, 1, root 5, 2 squared 1, okay, fine, 2 squared 1 squared, like that will go. See, you will find the pattern easily. So, here you will notice this, and then how will you take this? So, see, let's say I will take this as my radius. I am constructing the circle. Forget all of this, okay? Forget this line, forget this line, forget this line, this line. Take only this line. Now imagine this is the number line. This is 0, this is 1. So this distance is 1 centimeter. Now, if I take the compass measurement of this line, if I take compass measurement of AC, okay, I will place the compass pointer on A. This is 0, fine, A, and I'll put the pencil on C. I will draw a line like diding here. So this is my root 3. Like that you will do for root 2, you will take compass measurement of this hypotenuse and then you will draw. Simple, easy. Now, there is the spiral also, okay. So like if you continue like this, root 3, okay, root 3, you will have 2 here, 3, 1, root 3 square plus 1 square equals to 4, root of 4 is 2, you have this is 2 and then like it will go on, you can find all the roots. It's a big spiral, it will go like this, this. Now, the next thing that you have newly added, no, you have this thing called proof of irrationality. Fine. Now, see, this was there in 10th before. Now it came to 9th. So, look at this properly, check this properly. Fine. Okay. Now, let's say, how do I prove? Prove root 2 is irrational. Say, yeah. Fine. Now, first let's say I assume root 2 is rational. Root 2 is rational. I'll assume. Fine. Okay. Before we learn this, we'll just learn about this theorem. Because it will get, you have to use this. The theorem is, let's say we have a number p. It's a factor of a square. A is a number, it's a factor of a square. Then it means it's also a factor of a. Okay. So 3 is a factor of 36. So 3 is also the factor of root of 36, which is 6. No. Correct. Yes or no? Yes, no. Okay. No. So root 2 is rational. Now root 2 can be expressed in the form of p by q, where p and q are co-primes. No? Alright. Now I will bring this, I will square both sides. Okay. I can either bring it here and square or I can do it normally. So square both sides. Fine. Now 2 times q squared is equals to p squared. That's what you're going to get. Now this entire thing, right? You notice this theorem, 2 is a factor of p square. So now that means 2 is a factor of p also. So let's say I write p is a factor of 2k. So k is another number, you're adding another number. So p is equals to 2 times a number k. So I will replace this in place of p. So 2 into q square is equals to 2k whole square. Now 2 into q square is equals to 4k square. Now q square is equals to 4k square by 2. Q square is equals to 2k square. Alright. Fine. Q square is equals to 2k square. Now, you notice that, remember first we have taken that P, Q are co-primes. What is the meaning of co-prime? They are prime numbers and they don't have any other factor other than 1. They don't have any other factor other than 1. Just kidding. I mean, they don't have a common factor of 1. Okay, they don't have a common factor of 1. Sometimes they can also blah 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 blah. Now they are co-prime. They are co-prime. So, but however here, we see that P and Q have a common factor too. Then how is this happening? We knew that P and Q are co-prime and they don't have any other factor other than 1. Now this 2 is coming. No, don't forget me. I am also a factor of you. And say, now this is the contradiction. So, contradiction to this theory. Now, sorry, with the arrow supposed to be like this. So this proves that root 2 is irrational. Okay, this proves that root 2 is irrational. Okay, simple, easy, done. Now our last thing is rationalizing. Now what is rationalization? Making the denominator a rational number. How do you do this? Let's say I have a number called 1 by root 2. How do I convert this to a rational number? Tell me. Solution 1 by root 2 multiplied by the same number here, by root 2 root 2. You will get root 2 by root 2 into root 2 is 2. 2 by root 2. Now this is rationalized. Now if I want to convert 1 by 5 plus root 3 into a rational number, how do I do this? What is this? This is 5 plus root 3. This is gonna get some complicated blah 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 decimal thing. No. 1 by 5 plus root 3 times, what do you multiply? You don't multiply by 5 plus root 3. You will multiply by 5 minus root 3. The opposite. 5 minus root 3 by 5 minus root 3. Now you will get 5 minus root 3 as the numerator by, now this is a plus b into a minus b. What is the theorem? The identity. This is a square minus b square. So here you have to apply 25 minus 3 square, root 3 square, which is 3. Now 5 minus root 3 by 22 is our answer. No, yes, no, yes. Okay, over. Easy. No, yeah, yes. There you go. So, chapter is over. Bye guys. See ya. Bye.